Have you ever wondered just how solid a scientific fact really is? I mean, we think of data as this objective, hard truth, right? But what if I told you that entire conclusions, the kind you read about in headlines, can actually hinge on a single, solitary data point? We're going to explore the fascinating and honestly kind of terrifying world of outliers.
All right, so here's the plan. We're going to start by seeing just how fragile these published findings can be. Then we'll dive into the absolute chaos of how researchers are handling these weird data points right now. And finally, we'll walk through a clear, powerful solution that can bring some serious order to this mess.
So let's kick things off with a real world example. This isn't some made up scenario. This is a story from a top tier journal that shows you exactly how high the stakes are when we're talking about data.
Seriously, think about that for a second. In a study with, say, dozens or even hundreds of pieces of data, how many would you have to take out to make a so-called significant finding just poof, completely disappear?
The answer is, well, it's pretty shocking. It's just one. A single observation can be the only thing standing between what we think is a groundbreaking discovery and a total statistical illusion. Let me show you how. So, picture this. Back in 2003, a study looked at the link between a CEO's personality and how well their company was doing. Now, they had a pretty small sample, only 17 CEOs. But from that tiny group, they reported 17 statistically significant findings. That's a lot. Well, a few years later, another group of researchers got curious. They looked at that study and wondered, just how sturdy are those 17 findings really? So they decided to put them to a very simple but very brutal test. What they did was this. They reran the original analysis 17 times. Each time, they just removed one CEO. And the result? It was an absolute bombshell. 16 of the 17 facts just vanished. Only one single finding was strong enough to survive having any single person removed from the data. And this table, this really shows you the scale of the collapse. I mean, look at this. 7 of the original findings were so weak, they depended on just one specific CEO being in the dataset. And the kicker? Check out the bottom row. 4 of the findings disappeared when almost any single CEO was removed. That right there is the 1-point problem in action. Now, you might be thinking, okay, that's just one flawed study. But here's the thing, it's not. This kind of fragility exists everywhere because as a scientific community, we just haven't agreed on how to deal with outliers. It is a fundamental methodological mess. To really get to the bottom of this, the authors of our source paper did a massive review. They dug into dozens of textbooks and over 200 research articles to see, what are the experts saying and what are researchers actually doing? And what they found was, well, chaos. For starters, they found at least 14 different ways that experts even define what an outlier is. Then, get this, there are 39 different techniques being used to try and spot them in a dataset. And once somebody finds one, there are 20 different suggestions for what to do next. Do you delete it, change it, ignore it? Nobody seems to agree. And all this confusion leads to huge problems. Researchers often don't tell you what they did. A lot of the time, they use methods that don't even make sense for their own definition. And maybe worse of all is this common idea that outliers are just errors that need to be deleted, which means we might be literally throwing away our most interesting discoveries. So to cut through all this chaos, the authors propose this just a beautifully simple framework. Instead of lumping all these weird data points into one messy category, they argue we should think of them as having one of 3 distinct identities. Are we looking at a simple mistake, a really fascinating and unique case, or just a data point that's messing up the math? Answering that one question is the key to doing this right. First up, we've got the most straightforward type, the error. This is data that is just plain wrong. It's not a real observation, and it has no business being in your data set to begin with. And these things can creep in from anywhere, right? A simple typo when someone's entering numbers, a piece of equipment that's not calibrated correctly, or maybe you accidentally included someone in your study who didn't meet the criteria. These are just mistakes that need to be fixed or removed. Okay, next up, we have the interesting outliers. Now, these are totally legitimate, accurate data points. They're just different. They're way out from the rest of the pack. And the authors argue these aren't problems to be fixed. They are incredible opportunities for discovery. And this right here, this is a complete paradigm shift. Instead of seeing some extreme data point as a nuisance that's messing up your stats, you see it as a clue.
This might be the one case that leads you to a brand new theory or breakthrough insight. And finally, there's the third type, the influential outlier. Now, like the interesting ones, these are accurate data points, but they aren't actually fascinating or unique in any meaningful way. They are simple data points that, just because of where they sit, are warping your statistical results. They're the source of the whole one-point problem. You can even split these into two camps. Some influential outliers mess with the overall fit of your model, basically how well it explains the big picture. And others are more like snipers. They change specific predictions, like the slope of a line, which can totally flip your conclusion on its head. Okay, so that's the three types. It's a great framework, but how do you actually use it? Well, the authors provide a super clear step-by-step process that anyone can follow. And listen, the order here is everything. It's absolutely critical. You can't just jump ahead and start deleting points you don't like. You have to start, always, by methodically hunting for simple mistakes. So, step 1. You're on the hunt for errors. You use all your tools to find potential candidates. But you don't just delete them on site. You investigate. You go back to the source. If you can confirm it was a typo, great, you fix it. If you can't fix it, only then do you remove it, and you write down exactly why. And here's where the thinking really shifts. If a data point looks weird, but you cannot prove it's an error, you don't just delete it, it graduates. It becomes a candidate for an interesting outlier that deserves its own special investigation. It's only after you've cleaned up the errors and set aside the interesting cases that you finally turn your attention to that last group, the points that are just skewing the numbers. And even then, the key isn't to hide them. It's to understand their impact and report it transparently. So you see, this whole framework, it's not just a technical fix. It's really a new philosophy for how we should approach data analysis. And it's all built on the researcher's responsibility to be clear, to be logical, and to be honest. The whole thing really boils down to two guiding principles. Number 1, transparency. Just show your work. Tell your readers exactly what you did with outliers and why. No more secrets. And number 2, congruence. Basically, use the right tool for the job. Make sure the method you use to find an outlier actually matches the type of outlier you're looking for. And to make all this happen, the authors make one huge, game-changing recommendation. Every single research paper should have a dedicated section titled Outlier Detection and Management. This gives researchers a clear standard to follow, and just as importantly, it gives readers like you the power to check their work. And that really leaves us with a final thought. Now that you know about the one-point problem, now that you've seen the methodological mess, you have a new tool, a new lens. The next time you see a headline about a new study, you're empowered to ask the one question that is almost never asked but could change everything.